As we continue reading through the document on marking out and measurement, we will look at gauges. There are three basic types of gauge. You have marking gauge, cutting gauge, and mortising gauge. A marking gauge is used for marking lines parallel to the face edge and side on wood. It consists of a stock that slides up and down the stem, allowing various measurements to be taken. The gauge should be set using a steel rule that has a zero end. The spur, which is the sharp point, is pushed into the wood as the gauge is pushed or pulled along the length of the timber. It is important to hold the stock tightly against the edge of the timber to ensure that you mark a parallel line. A cutting gauge is used for cutting across the grain. It is used in the same way as a marking gauge but has a blade instead of a spur. The blade cuts the fibers across the grain, making it easier and neater to cut with a saw. A mortised gauge has two pins. One pin is fixed and the other is adjustable. It is used for marking two parallel lines where a mortise and tension joint is to be cut. The process of marking out is exactly the same as with the two other gauges. Support activity here. Describe the difference between a marking gauge and a cutting gauge. In Unit 1, make activity which should describe the use of marking out tools. Keep a photographic record of the stages of your manufacture and in the section on quality of manufacture. Show all the relevant processes in detail, including the measurement and marking out stages. This talks about Unit 1. Remember, this document we have is only on Chapter 2. Now, we have this as a mortise gauge. Remember, it is used for making two parallel lines where a mortise and tendon joint is to be cut. So the one to the right is the adjustable point, the adjustable pin. The one here to the left is the fixed pin. Now, depending on how this is set up, you can also have the one on the left adjustable and the one on the right fixed. With this one, it looks like the one on the right is the fixed one now. You turn this knob and it presses against the center. This knob over here, I would believe you have a screw thread over to this side, and as you turn it, you adjust the one to the left. Scribers. This is a scriber. A scriber is used to scratch the surface of metal and plastic lightly. If you are using a scriber on metal, it is a good idea to apply a coat of engineer's blue. It is a liquid with the color blue. This is a spirit-based liquid that is applied to a metal surface. When the scriber is dragged across the engineer's blue, it leaves a clean line which can be easily seen. So you rub the blue along the area which you're going to scribe. Then when you mark it with the scriber, it removes a line in the blue and you can easily see that line. It would not be so easy to see without the engineering blue. Punches. Center punches are used to make an indent on the surface where holes are to be drilled in metal, as shown in figure 2.5. So you have the center punch And this is the hammer that you use to hit the top of the center punch, and it sinks down into the metal, producing a hole. They provide a starting point for the drill and stop it skidding over the surface. Dot punches are used for marking the centers where dividers are to be used. They are similar to a center punch, except that the tips are ground at 60 rather than at 90-degree point. So the center punch is at 90, the dot punch is at 60, sharper point. Quick notes: scribers are used to scratch the surface of metal and plastic. Punches are used to indent metal surface. Do not mix these up. Stretch activity. Scribers and punches are made from a grade of steel known as tool steel or high carbon steel. Investigate why this is. Which property of high carbon steel makes it suitable to be used in this way? So that's something for you to look up. Templates. A template is used when a number or identical shape or pattern needs to be marked out. You can use a template from any thin material. You can make a template for any thin material such as plywood or aluminum that is easy to draw around. Micrometers. A micrometer is a specialized instrument used to take very accurate measurements. The thimble, which rotates as the micrometer is tightened, has 50 equal divisions around its diameter, giving an accuracy of 0.01 millimeter. So that's the thimble. Yeah. A reading is taken by adding all visible whole numbers to the nearest 0.5 millimeters. The reading from the thimble, which will be between 0 and 0.49 millimeters, is added to the main reading to get the exact measurements. Although the micrometer provides a very accurate measurement, it can be difficult to learn how to read it. So here, name the tool and describe its use. That's the micrometer. Basic answers. Simply not able to recall the fact that the tool shown is a micrometer, or that the tool is used for measuring or taking accurate measurement. If you're not able to recall that, you get 0 marks here. Good answer, 1 to 2 marks. The tool is correctly identified and named as a micrometer, and it is correctly described as being used for measuring or taking accurate measurement. Now, the reading on the micrometer. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a little bit more. 12 plus. This lines up with 30, 31, 32, 33, 34, 35. So it's 30, 31, 32. Reading up. Past 30, one more stroke gives you 31, another stroke gives you 32. And that 32 stroke is lined up well for the center here. So the micrometer reading is 12 plus 0.32, which is 12.32. Let's get an even closer look at the micrometer. Notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a little more than 12. 12 plus, cut these marks. 25, 26, 27, 28, 29, 30, 31, 32. 32 lines up with the horizontal line here. So it's 12 plus 0.32. So these readings around the thimble are to the nearest 0.01 millimeters. This is 0.32 millimeters. So it's 12 plus 0.3, which is 2, which is 12.32 millimeters. So we have just read that micrometer. Wasting tools. We will look at wasting in a different video.